This is for mathematical methods. It's the 6th question, quiz number 4, question number 6. The question was, a customer buys avocados and she buys them separately, isn't allowed to touch them. She knows probably getting a ripe avocado is 0.4. How many avocados must she buy to ensure the probability of at least one ripe avocado being greater than 0.9? Okay, so this is finding n. So it comes out of 14c. So I know that avocados are binomial. I don't know n, but I know the probability of the ripe one is 0.4. And I want to know how many probability of at least one. Probability that A is at least 1 is being greater than 0.9. So method 1 is trial and error on ClassPad. So what I'm going to do is I'm going to, on my ClassPad, come up with interactive distribution discrete binomial CDF. On my own, my lowest number is 1. So 1. And I don't know my upper number, but let's say I guess some numbers, 8. And I'm saying that n is 8 and the probability of success is 0.4. And when I press that, I get much greater than 90%. I've got 0.99. So maybe I should try n equals 6. So you can see I'm just going to cycle through different n's and 0.95. So 6 is too big. How about I try 5? .92, so maybe I'll try 4. And 4 was too small. 5 is big, so you would need to buy 5 avocados because that would give you 92%, whereas 4 avocados is only 87%. So 5 avos are needed. So that's method number 1, trial and error. How would I show my method on the calculator? I would do like n equals 4, binomial CDF 1, 4, 4, 0.8 equals 4 was 0.8704 and n equals 5, binomial CDF 1, 5, 5, 0.8 and 5 was 92.22, therefore 5. That's enough for you to show I cycled through and found them. Okay, that's method number 1. Method number 2 is using graphs and tables, and it looks like this. I'm going to replace this with x. I'm going to replace this with x because x is the unknown, which is the n value. I'm going to copy of that. I'm going to jump out of here and go into graphs and tables. And paste, and then tick it. I'm going to change the window view or the table input, starting at 1, going up to 3rd, doesn't matter what I go up to, and steps has to be 1 in this case, and then I look down my table until I find higher than 90%. 5, same answer. And method number 3, which is the method that you would need to use if you were using your by hand methods. So avocados are binomial n 0.4. We're wanting the probability that x is bigger than or equal to 1 is bigger than 0.9. That's 1 minus the probability that x equals 0 is bigger than 0.9, which is the probability that x equals 0 is less than 0.1, which is n 0, 0.4 to the 0, 0.6 to the n, less than 0.1, That's 1, that's 1. 0.6 to the n is less than 0.1. And on my calculator, back into main, 0.6 to the power of x is less than 0.1 and solve for x. And I get x has to be bigger than 4.5. Therefore, n has to be 5.